Welcome to this lesson where I'm going to be talking about high availability or HA, fault tolerance or FT, and disaster recovery or DR. It's essential that you understand all three of these to be an effective solutions architect, and I want to make sure that you understand all of them correctly. Many of the best architects and consultants that I've worked with have misunderstood exactly what HA and FT mean. The best outcome of this misunderstanding is that you waste business funds and put a project at risk. Worst case, you can literally put lives at risk. So let's jump in and get started, and I promise to keep it as brief as possible, but this really is something you need to fully understand. Let's start with high availability. This is a term that most people think that they understand. Formally, the definition is that high availability aims to ensure an agreed level of operational performance, usually uptime, for a higher than normal period. And I've highlighted the key parts of that definition. Most students that I initially teach have an assumption that making a system highly available means ensuring that the system never fails or that the user of a system never experiences any outages, and that is not true. HA isn't aiming to stop failure, and it definitely doesn't mean that customers won't experience outages. A highly available system is one designed to be online and providing services as often as possible. It's a system designed so that when it fails, its components can be replaced or fixed as quickly as possible, often using automation to bring systems back into service. High availability is not about the user experience. If a system fails and a component is replaced and that disrupts service for a few seconds, that's okay. It's still highly available. High availability is about maximizing a system's online time, and that's it. Let me give you an example. Let's say we have a system which has a customer, Winnie. Winnie is a data scientist and uses a bespoke application to identify complex data trends. Now, this application runs on a single server, let's say inside AWS. The application probably has other users in addition to Winnie. It's an important application to the business. If it's down, the staff can't work. If they can't work, they don't generate value to the business. And of course, this costs the business money. If we have a failure, it means that the system is now suffering an outage. It's not available. System availability is generally expressed in the form of a percentage of uptime. So we might have 99.9 or 3 nines, and this means that we can only have 8.77 hours of downtime per year. Imagine only being able to take a system down for 8.77 hours a year. That's less than 1 hour per month. It gets worse though. Some systems need even higher levels of availability. We've got 99.999% availability, or 5 nines, and this only allows for 5.26 minutes per year of downtime. That means for all outages during a year, you have 5.26 minutes. That includes identifying that there's an outage, identifying the cause, devising a solution, and implementing a fix. And an outage in this context is defined as something which impacts that service, so impacts your users. Now, fixing Winnie's application quickly can be done by swapping out the compute resource, probably a virtual server. Rather than using time to diagnose the issue, if you have a process ready to replace it, it can be fixed quickly and probably in an automated way. Or you might improve this further by having 2 servers online constantly, one active and one standby. In the event of a failure, customers would move to the standby server with very close to 0 downtime. But, and this is a key factor about high availability, when they migrate from the active server to the standby server, they might have to re-log in or might have some small disruption. For high availability, user disruption, while not being ideal, is okay. It can happen, because high availability is just about minimizing any outages. Now, this might explain it a little better. This is a real-world example of something which has high availability built in. It's a 4x4. If you were driving in the desert with a normal urban grade car and it got a flat tyre, would you have a spare? Would you have the tools ready to repair it as quickly as possible? In a desert, an outage or delay could have major impacts. It's risky and it could impact getting to your destination. So an example of high availability is to carry a spare wheel and the tools required to replace it. You would of course need to spend time changing the tyre, which is a disruption, but it could be done and it minimises the time that you're out of action. If you don't have a spare tyre, then you'd need to call for assistance, which would substantially increase the time you're out of action. So high availability is about keeping a system operational. It's about fast or automatic recovery of issues. It's not about preventing user disruption. While that's a bonus, a highly available system can still have disruption to your user base when there is a failure. Now, high availability has costs required to implement it. It needs some design decisions to be made in advance, and it requires a certain level of automation. Sometimes high availability needs redundant servers or redundant infrastructure to be in place, ready to switch customers over to in the event of a disaster to minimize downtime. Now let's take this a step further and talk about fault tolerance and how it differs from high availability. When most people think of high availability, they're actually mixing it up with fault tolerance. Fault tolerance in some ways is very similar to high availability, but it is much more. Fault tolerance is defined as the property that enables a system to continue operating properly in the event of a failure of some of its components, so one or more faults within the system. Fault tolerance means that if a system has faults, and this could be one fault or multiple faults, then it should continue to operate properly even while those faults are present and being fixed. It means it has to continue operating through a failure without impacting customers. Imagine a scenario where we have somebody injured. So we've got Dr. Abby and she's been told that she has an urgent case of an injured patient. And we'll call this patient Mike. Mike has been rushed to the hospital after injuring himself running. He's currently being prepped for a surgical procedure and is in the operating room and currently under general anaesthetic. While he's unconscious, he's being monitored. And this monitoring system indicates when to reduce or increase the levels of anaesthetic that Mike gets. It's critical that this service not be interrupted ever. The system uses underlying infrastructure on premises at the hospital. Now, in the event of a system failure, if it was just a highly available system, the server could be replaced, or another server could be included in an active standby architecture. In either case, the swap between the servers would cause a system error, a disruption. However quick the fix, however small that disruption, in certain situations like this, any disruption can be life-threatening. This is an example of a situation where high availability isn't enough. Fault-tolerant systems are designed to work through failure with no disruption. In this example, we might have the system's monitor communicating with two servers at the same time in an active-active configuration. The monitor is connected to both servers all of the time, so this is not just a simple failover configuration. If a server failed, it would drop down to just communicating with the remaining server, and as long as one server remains active, the system is fully functional. Now we could take this further, adding a second monitoring system, itself with connections to both servers. That way, one monitor can fail, one server can fail, and still the service would continue uninterrupted. We could even eliminate the human dependency in this system and add an extra surgeon, Dr. Abby's twin. Most people think that HA means operating through failure. It's not. HA is just about maximising uptime. Fault tolerance is what means to operate through failure. Fault tolerance can be expensive because it's much more complex to implement versus high availability. High availability can be accomplished by having spare equipment, so standby physical or virtual components. As long as you automate things and have these spare components ready to go, you can minimise outages. With fault tolerance, it's about more than that. You first need to minimize outages, which is the same as HA, but then you also need to design the system to be able to tolerate the failure, which means levels of redundancy and system components which can route traffic and sessions around any failed components. Now remember the example I used for high availability, the 4x4 in the desert. There are situations where we can't pull over to the side of the road and change a component. An example of this is a plane which is in the air. A plane needs to operate through systems failure, so through an engine failure, for example. If an engine fails, the plane can't simply stop and effect repairs. So a plane comes with more engines than it needs. It comes with duplicate electronic systems and duplicate hydraulic systems, so that when it has a problem, it just carries on running until it can safely land and effect repairs. AWS is no exception to this. Systems can be designed to only maximize uptime, which is high availability, or they can be designed for mission or life critical situations, and so designed to operate through that failure, which is fault tolerance. As a solutions architect, you need to understand what your customer requires. A customer might say that they need HA or fault tolerance while not understanding the difference. Fault tolerance is harder to design, harder to implement, and costs much more. Implementing fault tolerance when you really needed high availability simply means you're wasting money. It costs more and it takes longer to implement. But the reverse, implementing high availability when you need fault tolerance, means that you're potentially putting life at risk. A highly available plane is less than ideal. Understand the difference. If you don't, it can be disastrous. So let's move on to the final concept, which is disaster recovery. The definition of disaster recovery is a set of policies, tools, and procedures to enable the recovery or continuation of vital technology infrastructure and systems following a natural or human-induced disaster. So while high availability and fault tolerance are about designing systems to cope or operate through disaster, disaster recovery is about what to plan for and do when disaster occurs, which knocks out a system. So if high availability and fault tolerance don't work, what then? What if your building catches fire, is flooded, or explodes? Disaster recovery is a multiple stage set of processes, so given a disaster, it's about what happens before, so the pre-planning, and what happens afterwards, the DR process itself. The worst time for any business is recovering in the event of a major disaster. In that type of environment, bad decisions are made, decisions based on shock, lack of sleep, and fear of how to recover. So a good set of DR processes need to pre-plan for everything in advance, build a set of processes and documentation, plan for staffing and physical issues when a disaster happens. If you have a business premises with some staff, then part of a good DR plan might be to have a standby premises ready. And this standby premises can be used in the event of a disaster. That way, done in advance, your staff, unaffected by the disaster, know exactly where to go. You might need space for IT systems, or you might use a cloud platform such as AWS as a backup location. But in any case, you need the idea of a backup premises or a backup location that's ready to go in the event of a disaster. If you have local infrastructure, then make sure you have resilience. Make sure you have plans in place and ready during a disaster. This might be extra hardware sitting at the backup site ready to go, or it might be virtual machines or instances operating in a cloud environment ready when you need them. A good DR plan means taking regular backups. This is essential. But the worst thing you can do is to store these backups at the same site as your systems. It's dangerous. If your main site is damaged, your primary data and your backups are damaged at the same time, and that's a huge problem. You need to have plans in place for off-site backup storage. So in the event of a disaster, the backups can be restored at this standby location. So have the backups of your primary data off-site and ready to go, and make sure that all of the staff know the location and the access requirements for these backups. Effective DR planning isn't just about the tech though, it's about knowledge. Make sure that you have copies of all your processors available. All your logins to key systems need to be available for the staff to use when they're at this standby site. Do this in advance and it won't be a chaotic process when an issue inevitably occurs. Ideally, you want to run periodic DR testing to make sure that you have everything you need, and then if you identify anything missing, you can refine your processes and run the test again. If high availability is a 4x4, if fault tolerance are the resilient systems on large planes, then effective DR processors are pilot or passenger ejection systems. DR is designed to keep the crucial and non-replaceable parts of your system safe, so that when a disaster occurs, you don't lose anything irreplaceable and can rebuild after the disaster. Historically, disaster recovery was very manual. Because of cloud and automation, DR can now be largely automated, reducing the time for recovery and the potential for any errors. As you go through the course, I'm going to help you understand how to implement high availability and fault tolerant systems in AWS using AWS products and services. So you need to understand both of these terms really well and disaster recovery. So in summary, high availability is about minimizing any outages, so maximizing system availability. Fault tolerance extends this, building systems which operate through faults and failures. Don't confuse the two. Fault tolerance is much more complex and expensive. It takes a lot more time and effort to implement and manage. I'll help you as we go through the course by identifying how to implement systems which are highly available and how to implement systems which are fault tolerant. AWS provide products and services which help with both of those or just help with one or the other, and you need to know the difference. Disaster recovery is how we recover. It's what we do when high availability and fault tolerance don't work. And AWS also has many systems and features which help with disaster recovery. And one of the things that the exam tests will be your knowledge of how quickly you can recover and how best to recover given the various different products and services. And I'll highlight all of this as we go through the course. At this point, that's everything I wanted to cover. So thanks for listening. Go ahead, complete this video, and when you're ready, I'll see you in the next.